Hi, everybody. I just want to give you a little help on your lab. The lab is in a really weird place. It's at the end of the reading. Here you can see it's at the end, the page 4 of 3.05a. Okay. So there are several things you need. The lab report is here. Download it into Google, your Google Drive. Then you can open it up and put your answers in there. You will also need, we probably need this VSEPR chart. This shows you all the structures and the names of it. You will also need this electronegativity chart because you will need to, in several places in the charts, find bonds and find the electronegativity differences between the two elements that are bonded in that bond. So I have done water here. The electronegativity difference between of the bond. So hydrogen is pulling at 2.22, oxygen is pulling at 3.44. So we just subtract those and we get what, 1.22? 1.22. Anything below 1.70 is a covalent bond. And since we get that kind of high number, what happens is, and this goes back to the polarity thing. What that means is oxygen can pull this electron from hydrogen closer to it. So what happens is these bonds actually shrink because the oxygen can pull so much harder than the hydrogen. So it pulls those bonds closer to it. And because it pulls the electrons so much closer to it, electrons are negatively charged. That means for this molecule, it's kind of more negatively charged up here by the oxygen because it's got more of the electrons around it, circling around it, than it does the hydrogen. So the hydrogen are kind of positively charged on their end. So when we talk about a polar molecule, it means the charges around the molecule are kind of separated. So the molecule has one side that's more positive and the other side more negative. So this is what we call a polar molecule. And so in your lab, you're going to figure out what things are polar and what things are non-polar. Okay? So let's talk about something that would be non-polar. Vegetable oil. I'm not sure. Vegetable oil would be a bunch of carbons with some hydrogen. I'm not sure of the. Let's just go with this. So you see how everything's nicely distributed and the electronegativity isn't so much. So there isn't like one isn't positive and the other end negative. Okay. This is what we call non-polar because the charges are so just kind of nicely distributed. And one end isn't negative and one isn't positive. And so there's not an overall charge for this, and this is what we call nonpolar. Okay, so if I were to mix these two, a polar molecule and a nonpolar, if I was like, go to my kitchen, get them out, put them together, they would not mix. So the big idea for this lab is like, and this is what I want you to remember. If you need to screenshot this, please do. Like dissolves alike. So what does that, what the heck does that mean, right? That means if I put two polar molecules together, let me think. they are going to mix with each other. They're going to dissolve each other.
Let me think.
If
What
I
would
put
be a
a
nonpolar?
nonpolar
Let me think.
and a nonpolar together,
It is not
like
coming to me.
dissolves like. Those two are going to dissolve. They're going to mix.
Salt would
But
be ionic.
in your lab, this will happen. If I put a nonpolar and a nonpolar together, okay, I'm sorry, blah, already did that. A polar together. If I put those two together, they will not mix. So if you've ever gone to the kitchen and you put water and oil together, do they mix together? No, they don't mix together. One sits on top of the other, right? And it doesn't matter how much you shake it, one's still going to be on top of the other. So they're not going to mix. Well, that's what this is. That's when you put a nonpolar molecule and a polar molecule together, they will not dissolve because they are not alike. And this is what you're going to be doing in your lab. You're going to go to your kitchen, you're going to get some stuff. You know water is polar, so you're going to test out all these things with water first. So it's like vinegar and vegetable oil, rubbing alcohol, and salt, and all these things, and you're going to put them with water. So if they mix, right? If they mix with water, what do they have to be? What kind of molecule do they have to be? Anybody? So we know that water is polar. So if anything in your lab mixes, dissolves in water, it's got to be polar, right? If it doesn't mix with water, then it has to be this other thing where it must be nonpolar. So by knowing what water is, then you can figure out what all these other things are. And that is basically your lab. And also in your lab, it asks you to draw some shapes. So and then name the shapes. And over in your reading on page 2, it shows you a chart, and you should use that chart for your lab. Okay, that's going to give you all the shapes for your lab, and I definitely want you to use it. Let me show you what it looks like so you know what I'm talking about. All right, so everybody see Buzz here? This is page 2 of the molecular structure reading 3.05a. And this chart on page 2 shows you what all the shapes are. So if you have 2 atoms bonded, you're going to get a linear shape. So here's the VSEPR structure right here, and here's the molecular structure. So in 2 atoms, those 2 are going to be the same. So if you get, let's say, some double or triple, but you still have this, but you have more atoms bonded now, you're still going to get these linear shapes. All right, but then if you get even more atoms together, then they start forming other shapes. So here you have 3 bonds and no other unbonded molecule or electrons. You get a trigonal planar, so it's flat. Here, and it shows, and it tells you the VSEPR shape and the molecular structure, and those are on charts on your lab. And here, and this is what water would be right here. It's 120, this one right here. It has, this would be the oxygen, these would be the hydrogen,
The hydrogen would be 120 apart. Oh, I'm sorry, this would not be water because there would be 2 unbonded electrons here. But this is what we call bent in the molecular structure, but it's still a triagonal planar in the VSEPR. And all VSEPR is, it's the valence shell electron pair repulsion theory, and that just means electrons don't want to get close to each other, and so they push each other far apart, and that's what makes these shapes. And so then we have this one. Now here is water right here, because it's got 2 pairs of electrons that are not bonded, but these pairs of electrons still push all the bonded pairs down, so it still participates in the structure. So here the VSEPR shape is tetrahedral, and tetra means 4. So 2 bonds plus these 2 unpaired electrons, so tetrahedral. But the molecular shape is just bent because it doesn't take into account these unbonded electrons. So it just takes into account these 2 bonds right here, and so it says it's bent. And so these are all the shapes. You just have to use this chart in your charts on your lab, and then you're good to go. So just reference this and you're good. So it's on page 4 of your reading. The lab is, you download that molecular lab report into Google Docs and then fill it out. Use this, oh, here's a VSEPR geometry chart. Here's electronegativity chart, use that. And then you have to actually go and do this in your kitchen. So fun times, you actually get to do a lab in your kitchen. Go freak out your mom.